to stay awake or fall asleep. Just this is the abode of Shri Shri Radha Damodara, so please feel at home. My apology that I could only offer 2 language options, Chinese and Chinese English. So if you during the class find it very hard to understand Chinese English, let me know. I'll try to explain in Chinese. So today we'll start with speech and then move on to lecture style presentation. Nama Om Vishnu Padaya Krishna Prishtaya Bhutale Srimate Bhaktivedanta Swamin Iti Namine Namaste Sarasvate Deve Gauravani Prachadine Nirvishesha Shunyavadi Paschata Desha Tadine Hare Krishna 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 Hare 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 Rama 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 Hare Hare. The title of the speech is The Size and the Age of the Universe. How large is the universe, and how old is it? These centuries-old questions are among the top compelling mysteries that fascinate human beings and carry implications on science, religion, and philosophy alike. Equipped with the state-of-the-art telescopes and computers, astronomers today estimate that the universe is about 13.7 billion years old and has a diameter of 93 billion light years. The Bhagavatam gives different answers. In Canto 3, Chapter 11, that the universe, which looks to Mahavishnu like a Paramanu, the material manifestation's ultimate particle, the center of 500 million yojanas, which is translated by Srila Prabhupada as 4 billion miles. The age of the universe in the Bhagavatam context can be estimated based on the age of Lord Brahma, who is the creator within the universe. We know from chapter 11 that Lord Brahma has lived 50 Brahma years and is currently in the first day of his 51st year. We also know that 1 day and 1 night of Lord Brahma is about 8.6 billion years for humans. Taking these 2 together, we can estimate that the age of the universe is about 155 trillion years. The disagreements are obvious. For the size of the universe, astronomers' estimation is more than 10 to the power of 14 times larger than the Bhagavatam statement. For the age of the universe, the astronomers' estimations is over 10,000 times smaller than the Bhagavatam statement. There may be a number of ways to shed light on these apparent disagreements. What we'll discuss here is a perspective that is based on a distinction between the universe seen through telescopes and computers and the universe described in Srimad Bhagavatam. The universe discussed in today's astronomy forum is called the observable universe. Basically, this is a region that comprising everything an observer on Earth can see at present when look out into space. To estimate parameters such as age and distance, astronomers collect varieties of signals such as visible light, X-rays, radio waves, gravitational waves, etc., that are emitted from an observed object, such as stars or galaxies. Since it takes time for these signals to travel from their source to an observer on Earth, the image of stars or galaxies we see at present is a picture of them in the past, which comprising signals that were emitted from them long ago and were just reaching us right now. Meanwhile, the current whereabouts of these stars or galaxies is unknown to the observer. For an interesting example, since it takes 8.3 minutes for the sunlight to reach Earth, how the sun look like at present is actually how it looked like 8.3 minutes ago. That's to say, if the sun vanishes at the very moment, we will not be aware until 8.3 minutes later, when the sunlight disappears before our eyes. For the observable universe, its age can be estimated, is viewed as the time elapsed since the universe expanded from an initial state of high density and temperature, the Big Bang. And this age can be estimated by different approaches. One approach is to relate it to the oldest observable stars. Another approach is to estimate the expansion rate of the universe and use that rate to extrapolate the time it takes for the universe to expand from its initial state to the current state. What about the size? The size of the universe can be estimated by taking into consideration two factors. One is the age, and the other is the expansion rate. We just said that the observable universe is 13.7 billion years old. Given that signals cannot travel over time and space faster than the speed of light in vacuum, the maximum observable distance for us at present in any direction is 13.7 billion light years. Is that the radius of the observable universe? Now remember, we said the universe is also expanding. That means distant objects would have been moving further away from us since they emit the signals that were just reaching us right now. So you put in these two together, the universe is estimated to have a radius of about 47 billion light years. What we can know from this discussion is, in terms of the observable universe, size and age are not two independent variables. Size, in fact, is extended by the age. For a crude example, one may take it as size equals A times age plus B, where A and B are greater than 0. This size, as you can see, is not a constant that remains similar and stationary over time. As time passes, the size will also change. If you think about it, when looking at the observable universe, we are actually looking at an aspect of the history of the universe that leads to what can be observed by us today. Going back to Bhagavatam, in Canto 5, Chapter 16 to 26, Shukadeva Goswami gave a panoramic view of the universe that includes the vertical and horizontal structure, the movements of stars and galaxies, planets, and inhabitants in different regions of the universe. Such a panoramic view, however, is not attainable by astronomers with the current observation technology, because most of the celestial objects are separate from us by a considerable distance in space and time. To attain a panoramic view, astronomers need to see the universe at present, rather than the universe in the past. This would require instantaneous, faster-than-light communications between the observed object and an observer. In this regard, since the universe observed through telescopes and computers and the universe seen described in the Bhagavatam are not the same, it is not surprising that they give different measurements. Maybe someday observation technology could be advanced and astronomers could gain a better view of the universe. Still, with the sensory and intellectual power given to them, what they can observe would be limited. Except for those who create and maintain the universe, and those who learn from them, who would be able to know the universe in full scale? In astronomy, the universe is regarded as a physical object that is measured by parameters and equations. In the conversation between Shukadeva Goswami and Maharaja Parikshit, the universe is seen as a gigantic universal form of the Supreme on which all living entities repose. In his inquiry, Maharaja Parikshit expresses, when the mind is fixed upon the Supreme Personality of Godhead in his external feature, made of the material modes of nature, the gross, universal form. It is brought to the platform of pure goodness. In that transcendental position, one can understand the Supreme Personality of Godhead, Vasudeva, who, in his subtler form, is self-effulgent and beyond the modes of nature. O my Lord, please describe vividly how that form, which covers the entire universe, is perceived. In astronomy, it is said, when one looks out in space, one looks back in time. The farther one sees, the more one looks into the distant past. With the telescope of Srimad Bhagavatam, this statement can be rephrased. When one looks out in space, one looks at the Supreme. The more one studies, the more likely one's devotional love for the Supreme Personality of Godhead increases. This is the end of the speech. I hope it will provide a good setting for the upcoming topics. On that note, we move on to the next topic of today, which is Maharaja Priyavrata and 7 Islands and 7 Seas. Who is Maharaja Priyavrata? He is the son of Svayambhuva Manu and his wife Shatarupa. They're born directly from Lord Brahma. And although Priyavrata Maharaj is himself not a Manu, he is the father of the 3rd, 4th, and 5th Manus. Currently, we are in the reign of the 7th Manu. So almost half of the Manus we have till now comes from Maharaja Priyavrata. And he has a famous nephew, Dhruva Maharaj. And he is the great-grandfather of Rishabhadev, an avatar of Lord Vishnu. This picture shows when Priyavrata was about to take up the renounced order of life. In the association of Narada Muni, his father and grandfather intervened. They persuaded him to take up the role of a king. As a result, Priyavrata ruled the universe for 1.1 billion years. That is a very long time in the Bhagavatam context. It is about 255 yuga cycles, or 3.6 manvantaras, or 3 hours for Lord Brahma. During his reign, he drove his chariot behind the sun, and the rims of his chariot created impressions that later become 7 oceans, dividing the Bhumandala into 7 islands. And he later on gave sovereignty over these 7 islands to 7 of his sons. Here's a depiction of Bhumandala. You can see a concentric series of concentric circles. The innermost piece of land is the first island. Surrounding the first island is the first ocean. Outside the first ocean is the second island, and then the second ocean, etc. All the way we go up to the 7th ocean, which is the light blue circle over here. Outside of the seventh ocean is a circle in green. This is called the inhabited land. Outside of the inhabited land is a circle in yellow. This is called the golden land. Surrounding the golden land is a circular mountain called Loka mountain. Outside of the Loka mountain is this region called Aloka Varsha, the uninhabited land. Here's a list of the names of these 7 islands and 7 seas. The first island is called Jambu Dwipa. Jambu means rose apple tree, and Dwipa means island. Its first syllable, dvi, means 2, and the second syllable, pa, represents apa, which means water. So that which has water, apa, on both sides, dvi, is called an island, dwipa. You may notice that the name of the fifth ocean is called the Milk Ocean. Please note that this is not the Milk Ocean where Kshirodakashayi Vishnu resides. Here is a close-up illustration of the 7 islands and 7 seas. The width of these 7 islands or 7 seas follows an interesting pattern. Beginning from the innermost islands or sea, the width of the next island or sea is twice as big as the previous one. Here is a list. You can see the first island or sea has a width of 100,000 yojanas. The width of the second island or sea is 200,000 yojanas. The third island or sea has a width of 400,000 yojanas. When we go all the way up to the seventh island or sea, that width has become 6,400,000 yojanas. Question: what is the distance from Mount Sumeru to the outer edge of the nth sea? Let's take a closer look. We copied the depiction and the list of numbers here. Now we let Rn be the distance from Mount Sumeru, which is the center of the first island, to the outer edge of the nth sea in 100,000 yojanas. So R1 is the distance from Mount Sumeru to the outer edge of the first sea in 100,000 yojanas. And that is the radius of the first island, which is 1 minus 0.5 plus the width of the first sea, which is 1. And this gives us 2 minus 0.5. R2 would be the distance from Mount Sumeru to the outer edge of the second sea in 100,000 yojanas. And this would be the width of the second island, which is 2, plus the width of the second ocean, which is also 2, and plus R1. Everyone follows? Yes? Yes? This can be written as 2 to the power of 2 plus 2 minus 0.5. Let's do one more. R3 will be the distance from Mount Sumeru to the outer edge of the third sea. And that is the width of the third island, which is 2 to the power of 2, plus the width of the third ocean, which is also 2 to the power of 2, plus R1. And this gives us 2 to the power of 3 plus 2 to the power of 2 plus 2 minus 0.5. Now, for general term n, what Rn will look like? We can observe the pattern that is observed in R1, R2, and R3 and infer that Rn will be 2 to the power of m plus 2 to the power of m minus 1 plus all the way down to 2 to the power of 3 plus 2 to the power of 2 plus 2 minus 0.5. What does Rn sum up to? Let me show you a trick. We multiply 2 to this equation on both sides. So the left side will become 2 times Rn. And on the right side, each of these terms is multiplied by 2. So it becomes 2 to the power of m plus 1 plus 2 to the power of n plus 2 to the power of m minus 1 all the way down to 2 to the power of 3 plus 2 to the power of 2 minus 0.5 times 2, which is 1. Now we call this equation A and this equation B. If we subtract A from B, on the left-hand side, we have Rn, which is what we want. And on the right-hand side, all these terms, beginning from 2 to the power of 2, down to 2 to the power from 2 to the power of n down to 2 to the power of 2, they canceled out. And what we are left with is 2 to the power of m plus 1 minus 1 minus 2 minus 0.5. And this boils down to 2 to the power of m plus 1 minus 2.5. So we have the formula. In 100,000 yojanas. Equivalently, we can write in 1 million yojanas by taking out a common factor 10 in this form. Later we'll see its usage. In astronomy, there is a Titius-Bode law. Titius and Bode are two German astronomers in the 18th century. Who is Acharya in our disciplic line that primarily lived in 18th century? Baladeva Vidyabhushana. While Baladeva Vidyabhushana was rigorously studying and preaching Krishna consciousness, Titius was examining the distance from the sun to the planets. And he discovered something that he found very interesting. What he discovered is a relationship that suggests Extending outward, the distance from each planet to the sun is twice as big as the previous one. And those planets that he studies are those that are known at his time, which are showed in this picture: Mercury, Venus, Earth, Jupiter, and Saturn. By the way, the numbers on this axis are in AU, astronomical unit, which is the average distance between the Earth and the Sun. Titius wrote to his colleague Bode, and the two work on to popularize the finding. The Titius-Bode law is something like this. dn denotes the distance from the Sun to the nth planets. When n equals minus infinity, dn represents the distance from the Sun to Mercury. And this distance is 0.3 times 2 to the power of minus infinity, which is 0, plus 4, which is 0.4 AU. When n is 0, dn represents the distance from the Sun to Venus. And this distance is going to be 0.3 times 2 to the power of 0, which is 1, plus 0.4, which is 0.7 AUs. When n is 1, this represents the distance from the Sun to the Earth, which is 1 AU by definition. You may notice that this formula looks similar to the formula that we just derived, although they represent different meanings. The Titius-Bode formula is about distance from the Sun to the planets, and our formula is about the distance from Mount Sumeru to the outer edge of the seas. Here's a plot, shows the Titius-Bode law predicted distance, which is the red line, versus the actual distance, which is the blue line. Note that neither Uranus nor Neptune, Pluto series were discovered when Titius postulated his formula. As it turned out, the formula works well up to Uranus, which happens to be the 7th planet in the solar system, given that Ceres is an asteroid. Despite many years of investigation, no explanation has been found for any underlying reason that planets should or do follow this law. Most of the researchers now regard the Titius-Bode formula as an interesting mathematical coincidence with reality. So, next time, when someone tells you about the Titius-Bode formula, you can tell them about Maharaja Priyavrata, Bhumandala, the 7 islands, 7 seas, and of course, Srimad Bhagavatam. That's about Maharaja Priyavrata. And let's move on to see Vivasvan, Aruna, and the movement of the sun. Vivasvan and Aruna are the sons of Kashyapa Muni and daughters of Daksha in his second birth. Daksha originally was born directly from Lord Brahma. However, he was killed due to committing an offense to Lord Shiva. And he later on took his second birth in the 6th Manvantara. Vivasvan was born from Aditi, and Aruna was born from Vinata. Since Kashyapa Muni is one of the grandson of Lord Brahma, they are the great-grandsons of Lord Brahma. The sun god Vivasvan is the father of the 7th Manu, who is the current reigning Manu. From the 7th Manu came King Sudumna and King Ikshvaku. King Sudumna is also known as Ila, who is the wife of the moon god's son. And of course, we cannot forget that from Vivasvan came Maryada Purushottama, Sri Ram. The sun god chariot driver, Aruna, has a famous brother, Garuda, who is the personal carrier of Lord Vishnu. In this picture, we can see sun god is riding on his chariot that has one wheel and driven by 7 horses, who are named after the 7 chandas, meters of Vedic poetry. Aruna is riding in the front, driving the horses, and at the same time, he is looking backwards toward the sun god. Sun god chariot is quite large in comparisons to the islands and seas on Bhumandala. It is said that his chariot is 3.6 million yojanas long and 0.9 million yojanas wide. If we remember the width of the islands and seas, 3.6 million yojanas means 36 Jambudvipa put in together. And 0.9 million yojanas wide means 9 Jambudvipa put in together. That's a quite large chariot. The sun is not only related to Vivasvan and Aruna, it is a form of the Supreme. Srimad Bhagavatam says, the original cause of the cosmic manifestation is the Supreme Personality of Godhead, Narayana. When great saintly persons, fully aware of the Vedic knowledge, offered prayers to the Supreme Person, he descended to this material world in the form of the sun to benefit all the planets and purify fruitive activities. He divided himself into 12 parts and created seasonal forms, beginning with spring. In this way, he created the seasonal qualities such as heat, cold, and so on. According to the system of 4 varnas and 4 ashramas, people generally worship the Supreme Personality of Godhead, Narayana, who is situated as the sun god. The sun plays a significant role in our life on this planet. Shukadeva Goswami says, O king, the sun god and the sun planet divide all the directions of the universe. It is only because of the presence of the sun that we can understand what is sky, the higher planets, this world, and the lower planets are. It is also only because we can understand which places are for material enjoyment, which are for liberation, which are hellish and subterranean. All living entities, including demigods, human beings, animals, birds, insects, reptiles, creepers, and trees, the heat and light given. Furthermore, it is also because of the sun's presence that all living entities can see, and therefore he is called Drik Ishvara, the personality of Godhead presiding over sight. By the influence of his radiation, the sun heats the universe and maintains its proper order. Where does the sun located in terms of the Bhagavatam's universe? Shukadeva Goswami said, the sun is situated vertically in the middle of the universe, in the area between Bhurloka and Bhurvaloka, which is called Antariksha, outer space. The distance between the sun and the circumference of the universe is 25 Koti yojanas. In terms of this depiction, is approximately this area, highlighted in orange. What about the horizontal boundary? To this, Shukadeva Goswami said, by the supreme will of Krishna, the mountain known as Loka Loka has been installed as the outer border of the three worlds, Bhurloka, Urvaloka, and Svarloka, to control the rays of the sun throughout the universe. All the luminaries from the sun up to Dhruvaloka distribute their rays throughout the three worlds, but only within the boundary formed by this mountain. According to Srimad Bhagavatam, apparently the sun revolves around Mount Sumeru daily in a clockwise direction along with the stars. This revolution creates the day-night cycle for residents on Bhumandala. It is said, people living in countries at points diametrically opposite to where the sun is first seen rising will see the sun setting. And if a straight line were drawn from a point where the sun is at midday, the people in countries at the opposite end of the line would be experiencing midnight. This is pretty much relatable to our experience. If you call a friend or a relative in India in your morning time, it will be nighttime for them. If we take a closer look at the sun, we'll see the following. Although the sun moves counterclockwise, facing the constellations, with Sumeru mountain on its left, it also moves clockwise and appears to have the mountain on its right. The signs and constellations with Sumeru and Dhruvaloka on their right move with the wheel of time, and the ant-like sun and other planets move with them. The sun and planets, however, are seen in different signs and constellations at different times. This indicates that their motion is different from that of the zodiac and the wheel of time itself. We can understand from these two verses that with regard to the signs and constellations, the sun moves counterclockwise. It is seen at different constellations and signs at different times. At the same time, with respect to Bhumandala, it moves clockwise, with all the signs and constellations rising in the east and setting in the west. Now, based on these two verses, tell me, suppose on day 1, the sun and star reach their respective highest point in the sky at the same time. When the sun reaches its highest point in the sky on day 2, where would we find the star? Conversely, when the star reaches its highest point in the sky on day 2, where would we find the sun? Here's what we can see from empirical observation. As seen from the Earth, it takes 24 hours for the sun to reach the highest point in the sky in a consecutive day. The sun in its highest point in the sky means noontime. So the duration from one highest point to the next highest point of the sun is called a solar day, as we understood that our day-night cycle is decided by the sun. Here's a diagram you can see. Now, it takes less than 24 hours for the star to reach the highest point in a consecutive day. That means when the star is at its highest point on day 2, the sun has not yet reached its highest point. Here's an illustration. You can see this: when the star is at its highest point, the sun is somewhere over here. As a result, the sun appears to move with respect to the background stars at a rate about 1 degree eastward or counterclockwise per solar day. Why this is so? Shukadeva Goswami told this is due to the sun's own counterclockwise motion. Translating into the contemporary language, this is due to the Earth orbiting the sun. We can see from this image, the Earth spins on its axis on a daily basis, resulting in a day-night cycle on Earth. However, it does not just sit there and spinning. It also rotates around the sun. One complete rotation in 1 year. That's to say, when the Earth completes its 360 degrees rotation with respect to a background stars, its location in its annual orbit also changed. Because of this, he has to rotate 1 more degrees before the sun comes perfectly overhead again. And more spinning takes more time. In this case, it is about 4 more minutes. So, based on this information, tell me, when will the sun and the star reach their respective highest point in the sky together again? You get it? By the sun's own counterclockwise motion with respect to the background star, it will be 1 year later. So let's move on to see what constitutes a year in terms of the sun's movement. In Canto 3, Chapter 11, it is said, 2 solar movements, ayana, make 1 day and night of the demigods. And that combination of day and night is 1 complete calendar year, samvatsara, for the human being. This is also explained in Canto 5, where it is said, in the chariot of the sun god, the sun travels on the top of the mountain in an orbit called the samvatsara, encircling Mount Meru. The sun's path on the northern side is called Uttarayana, and its path on the southern side is called Dakshinayana. One side represents a day for the demigods, and the other represents their night. Note that the mountain in this verse refers to Manasotara mountain, which is a circular mountain in the middle of the 7th island. Also note that the movements, ayana, talked about here refers to the sun's own counterclockwise motion. And these 2 ayanas give rise to seasonal changes and changes in the duration of day and night. Shukadeva Goswami said, according to its movements, rising above, going beneath, or passing through the equator, and correspondingly coming in touch with various signs of the zodiac headed by Makara, Capricorn. Days and nights are short, long, and equal to one another. Until the sun travels to the south, the days grow longer. And until it travels to the north, the nights grow longer. As it is showed in this illustration, if we measure the sun's highest point in the sky at different time of the year, we'll see that it periodically goes up and down, which has an effect on the duration of day and night and the climate conditions. Here is how the sun's trajectory looks like from the earth. This devotee standing in the middle is facing southward from the northern hemisphere. This axis is the Earth spin axis. The upper end points to the north celestial pole, and the lower end points to the south celestial pole. The green plane here is the horizon, and the orange circles here, they are the trajectories of the sun's daily movement. When it is above the green plane, when the sun is above the green plane, it is daytime for us. And when the sun is below the green plane, it is nighttime for us. We can see that the sun appears to move along with the celestial sphere on any given day, but follows different circles at different times of the year. The sun is most northerly at the summer or June solstice, where we have the longest daytime in the northern hemisphere. As you can see, a large proportion of the orange circle is above the horizon. And the sun is most southerly at the winter or December solstice, where we have the longest nighttime in the northern hemisphere. As you can see, a large proportion of the sun's trajectory is below the horizon. The sun follows the celestial equator at the equinoxes. That is, the sun rises exactly in the east and sets exactly in the west, where we have day and night of equal length. In this illustration, the blue circle is the celestial equator, and the orange circle is the ecliptic, the trajectory of the sun's movement in a year. You can see for half of the year, the sun is below the equator, and for the other half of the year, it is above the equator. Interesting enough, the current definition of solar year is equivalent to the concept of samvatsara in Srimad Bhagavatam. A solar year is the period of time for the ecliptic longitude of the sun to increase 360 degrees. For example, from the winter solstice, the sun goes up to the summer solstice, and then he moves back to the winter solstice. This is exactly the concept that one samvatsara is comprised of two ayanas, Uttarayana and Dakshinayana. It's also interesting to point out that the civil calendar tries as much as possible to synchronize the solar year, or samvatsara, for various practical reasons, such as agricultural production, transportation, mercantile, solar, social, cultural life, etc. Now, let me show you a demonstration of the sun's clockwise and counterclockwise movement. I'm going to use a planetarian software called Stellarium. It simulates how the nighttime will look like from our point of view. Give me one moment. Okay. So this is pretty much where we are located. The green plane here is the horizon. And you can see a letter S here. It denotes that we are facing south. Now let me take off the atmosphere so that we can have a better view of the stars. We go a little bit to the east side and zoom out a little bit. And let me speed up time. You can see the stars, they're rising from the east and setting to the west. And let us try to find the sun at this moment. So here's the sun. Let's take a closer look at the sun. Let me zoom out a little bit so that we can have the east direction and the west direction at the same time. You can see the sun moves in a clockwise direction along with all the stars. And if we turn a little bit to the north, that even has a better view. Let me pause a little bit and turn on the equatorial grid. You can see this is where the north celestial pole is located. It means where the spin axis of the Earth points at. And these concentric circles, they are in parallel to the equator. And let me speed up time again. You can see the suns and stars, they're rotating as with the pivot of the north celestial pole in clockwise direction. Okay. Good. Now, what about the sun's counterclockwise motion? To this, we can fix a time and increase only the days. And pay attention to the background stars around the area of the sun. Now, you can see as we move the date, the background stars is moved relative to the sun in a western direction. That means if we take the background stars as a reference, the sun moves in an eastward or counterclockwise direction. Okay, and now let me show you the annual movements of the sun. And to this, let me turn on two lines that will help us better view. The first one is the ecliptic. As you can see, the orange line. This is the sun's annual trajectory. And then we can also pull over another line, the blue line. This is the Earth's equator. And let me also change a perspective so that we are going to be perpendicular to the equator. That means the north celestial pole is right above the head. And let me also turn off the horizon. Okay, here's the view. Give me one moment. Okay, so you can see here is the sun and this intersecting point where the blue line, the equator, intersects the orange line, the ecliptic. this is the equinox for us. And this is another equinox. And now the sun is approximately over here, today. Now, let me speed up time and give a focus to the sun. And pay attention to the sun's movement. Okay, you can see the sun is gradually moved in his annual orbit in a counterclockwise direction. And now he reached the highest point, the 90 degree over here, and now he is moving down. Going further, where he reached the equinox, and going down further here in 270 degrees, he reached the lowest point, the winter solstice, and then goes up again back to here, the spring equinox. Let me also turn on the constellation arts and figures. You can see the background science as the sun moves along its annual orbit. Now he is here at the equinox, and here you can see the constellation Pisces. And he moves to Aries, to Taurus, and then goes down the equinox, and again goes down further to the winter solstice, and then he moves up, going through a complete circle back to the equinox, spring equinox. Okay, let's go back. Have you noticed that the sun has different speeds at different times of the year? In Srimad Bhagavatam it says, while passing towards the north, towards the south, or through the equator, in accordance with the order of the Supreme Personality of Godhead, the sun is said to move slowly, swiftly, or moderately. What is this about? Here are some references given by two devotees. Antardip Prabhu, quoting Vayu Purana. At the southernmost point of its annual orbit, the sun is over Manasodara mountain, that is, over the seventh island. At the equinoxes, the sun is above a part of the sixth ocean, so he moves a little bit inward. At the northernmost point, he is over the sixth island, so he's moving further inward. Sadaputa Prabhu said the same, quoting Vishnu Purana. The sun moves near center when it moves north, and near edge when it moves south. Center and edge you can understand as the center of Bhumandala and the edge of Bhumandala. Therefore, the circumference of the sun's daily revolution orbit decreases and increases at different times of the year. To maintain the duration of the day-night cycle as a constant, the sun has to speed up and slow down accordingly. Here is an illustration. You can see the yellow spot here in the middle. This represents Mount Sumeru, the center of the mandala. And this circles in dashed line, they represents the sixth island, the sixth ocean, and the seventh island. You can see as the sun moves southward or outward, its circumference expands. And as he moves northward or inward, this circumference contracts. Translated into our experience in the northern hemisphere, this is the sun's moving close to or away from the north celestial pole. But the day-night cycle remains the same, more or less 24 hours a day. It is not that we have a 20-hour day sometime and sometime a 30 hours a day. So in this way, the sun, the linear speed of the sun goes up and down accordingly. Let's offer our respect and gratitude to Vivasvan and Aruna, the powerful and faithful servants of the Supreme Personality of Godhead. On this note, we conclude the Part 1 session. Thank you very much for your time and attention. Look forward to having you tomorrow. Hare Krishna. All glories to Srila Prabhupada. I give back to you 5 minutes to all of you. Online question. Online question? Oh, okay. We can take offline.